Hi, welcome. In this video, I'm going to show you how to perform a one-sample hypothesis test for testing a binomial proportion. The purpose is to test if a true binomial proportion equal to a specified value. The null hypothesis is P equal to P0. Alternative hypothesis HA is P not equal to P0. Or P less than P0, or P greater than P0. Okay. To perform these tests, there are actually two tests. One is the exact binomial test, and the other is a normal approximation-based binomial test. Okay. We need to load the library for the binorm. I just assume we already pre-installed this package. Let me run the code to load the library here. Next step is we need to specify the number of successes and the total number of trials. So here is x and n. X is 25 and n is 50. And also we need to specify P0. Here we assign the 0.5 to P0. And then we can perform the exact test. And the function is binom.test. So the syntax is here. Let's run it. And then you can print out the test result and interpret the results. So you can see it as a number of successes, a number of trials, and the p-value, and the confidence intervals, etc. You can include these into your reports. Next, let's try the normal approximation-based binomial test. The same thing, we're reading the x, n, and p0, and then we can use the R function for the prop.test to perform the normal approximation-based binomial test. And we can print out the results, and you can see it tells you it's a one-sample proportion test without continuity correction. Okay, and I think in general the exact test should be used when the sample size is small, for the normal approximation-based test, you need to check the assumptions that n times p and n times 1 minus p are both greater than 5. And these are the conditions for you to have a good approximation to the binomial distribution by a normal distribution. Okay, that's it. Thank you for watching. You have learned how to perform a one-sample binomial proportion test.